Okay, so this is the second part of our series on linear inequalities in one variable, and so still maybe a little bit of review. Here we're going to start off by talking about a compound inequality, which is simply two simple inequalities that are joined by the words and or. In example 20, we have the variable is in between two inequalities, so what's not written here but is understood is an and. So when you see the variable in between two inequalities, it's an and problem. And then obviously if you see the word or, it's an or problem, okay? Think about and as you want ham and turkey at Thanksgiving. If you don't get both, you're going to throw a tantrum and you're going to embarrass yourself. So ham and turkey, nothing else will make you happy. The or is a little bit different. At Thanksgiving, if grandma makes ham, you're happy. Or if grandma decides to make turkey, you're happy. If you get both, you're really happy. But you're okay with one or the other. You're not going to throw a fit and be a spoiled brat. So and is kind of a spoiled brat. You have to have both. Or is a little bit more reasonable. One or the other is okay. Okay, so that's what we're going to do. Now let's solve this. I see my variable in the middle, so automatically I know this is an and problem. Even though it's not written that way, even though you don't see the word and, the variable is in the middle of two inequalities, so it's an and problem. And what I'm going to do to solve this is actually split this up and write this as two separate inequalities. So I want to talk about this inequality, and I want to talk about this inequality. And I suggest you actually draw these loops around, that way you can know which inequalities you need to write out. So the first one I'm going to solve is -2 less than or equal to 3t minus 8. The other inequality I'm going to look at is 3t minus 8 less than or equal to 10. And now I'm going to just solve each one of these by hand. Pretty easy, very similar to what we did in the last video. So start off by saying plus 8 on both sides. I have -2 plus 8 is 6, less than or equal to 3t. Get t by itself by dividing by 3 on both sides. So I have 2 less than or equal to t. Okay, I'm done with this for now. I know it's an and problem. I want to get t by itself here, so I'm going to say plus 8 on both sides. Cancel out, so I have 3t equals 10 plus 8 is 18. Get t by itself by dividing. And t is, sorry, this should be a less than or equal to, so less than or equal to 6. So I've solved it. Technically I'm done. It didn't ask me to graph, so I can put a circle around this and say, hey, I'm done. But I'm going to go above and beyond and graph. Drawing a sketch. Like I did in the last video, it's a number line because we had one variable only. I always put 0 on my sketch, kind of as just a reference point. And then I put my other two numbers. I know 2 is to the right of 0, and 6 is to the right of 2. It doesn't have to be perfect, but it does have to be in a logical order. 2 comes after 0, and 6 comes after 2. I know for each of these inequalities, I see a line under it, so I'm going to need a closed circle for each one. And now I want to shade for each one. I'm going to shade for green. We always start by reading from the variable side first, so t is greater than or equal to 2, so I'm going to shade to the right for the green. Now for the red, t is less than or equal to 6, so I'm going to shade to the left. Now, since it's an and problem, the only piece of the graph that makes me happy is where both happen at the same time. So that's why I'm looking for the overlap, since it's an and. So the overlap happens right here between 2 and 6. So where both 2 and 6, in between those two values occur, that's what the graph would look like, okay? Both have to happen if it's an and problem. In example 22, we have an or problem. We know it's or because we see the word or. And all we need to do is just solve each one. No big deal. I'm going to start off with the first one by saying -3 on both sides. So 2x less than 5 minus 3 is 2. Divide by 2 on both sides. So x less than 1. Then or just falls down. For the other one, I would start off by saying +7 on both sides. So I have 4x greater than 7 plus 9 is 16. I'm going to divide by 4 on both sides. So x greater than 4. So I have x less than 1 or x greater than 4. Again, it did not ask us to graph, so technically I'm finished. But I'm going to go above and beyond and just go ahead and draw a sketch. Again, again, when I draw a sketch, I always put 0, and I put my numbers for my answers on the number line in a logical order. 1 comes to the right of 0, and 4 comes to the right of 1. Okay? I know for the green inequality, x less than 1, I have an open circle because I don't see the line. Same thing for the red inequality, x greater than 4. I do not see the line, so I need an open circle. Now I'm going to shade. For the green one, I have x less than 1, so I'm going to shade to the left. And then for the red inequality, I have x greater than 4, so I shade to the right. So my final answer is where either of these happens, so less than 1 or bigger than 4, either one makes me happy. So that's what my graph of this answer will look like. That's it for this video. If you've got any questions, please let me know. But other than that, this should be reviewed.